Okay, everyone. Thank you for being here. I'm Mehlam Shakir, and I'm the Chief Technology Officer at RippleTech. And I'm going to talk a little bit about security and auditing today, and how are you going to meet your security and compliance requirements for MySQL. But first of all, I just want to give a little background about the company and a little bit about myself. I'll keep it short. So who are we as RippleTech? Now, RippleTech was founded in 1998, and RippleTech's focus is IT, compliance, and data security. And we have over 650 customers, active customers today, in all different kinds of verticals. And we are located very close to Philadelphia, just outside of Philadelphia. So we are a venture-backed firm. And RippleTech originally, had one product called Logcaster. And Logcaster was a log management product. So all the logs that are generated by different security devices, operating systems, etc., all those are collected. We normalize the data. We put it into a reporting database. We report upon it. So it has been doing that since 1998. It originally started as a performance monitoring product. So it was looking for traces, in system logs that were related to performance. But then it, slowly became a compliance and security product. Then we introduced another product called Informant. And it was a small company that I had started several years ago, which became part of RippleTech. And what we were doing was we were trying to create logs where they were not there. So I had been working on Wall Street for many, many years in the NASDAQ trading environment. And as in the DBA department, was involved in infrastructure, was involved with some networking. And we used to have these security requirements many years ago. And people would come and tell us, monitor this database. This database has a lot of critical information about Bill Gates. I used to be at Goldman Sachs, so we used to have all these important people and important data out there. And we used to have a lot of Sybase servers. So every time we would try to audit using the tools and utilities provided by Sybase, we would run into an issue, because it would bring down the performance. So no sooner would we implement site security, somebody who had asked us to turn on the auditing would come back and say, hey, it's affecting our service levels. So, and we would not have much choice. Either we would keep the auditing at very, very high level, just log on, log off, and that's what it would turn out to be. So the requirement for auditing had been around for a while. And then as Sarbanes-Oxley and other compliance regulations started coming to the mix, it became even more important to collect even more data. Like now people didn't only just want to say who got on and off the system, but who's touching those sensitive tables. I want to audit select queries. So it was just becoming almost impossible to use the features within the DBMS to do any kind of auditing. Moreover, there are so many requirements in a real world situation, where this data not only has to be collected, but it has to be properly normalized, it has to be reported upon, it has to be aggregated. The data could have a lot of important information in it, so it has to be secured. You have to deal with all kinds of operating systems, all kinds of platform versions. So you get different versions of Sybase and Oracle and MySQL Server and DB2. So with all these versions, all these technologies, how are we going to normalize and get very similar kind of audit trails across the enterprise, bring it into one repository, report upon it, and show our internal auditors that, hey, we are looking at the data, and we know what's going on. So we started off from there, so we came up with a different architecture. We said we're going to monitor over the network, because the primary requirement was that the product must be non-intrusive, it should not affect the service levels. But I'll get a little bit more into the details of the architecture a little later on. But at the very high level, RippleTech operates under the Data Access Intelligence umbrella. So with its database monitoring product and with its log management product, what essentially we do is we look at anybody who's looking at important files, or look at within the transactions of the database. Now once you combine the two, you get better data security, because now we have covered files as well as databases. So that's the umbrella that we operate under. Okay, that's it about the company. Now this was a presentation we did with Forrester just a few weeks ago, and most of us over here, are from the DBA background, so we understand many of these issues quite well. Everyone here is a MySQL DBA? No? Involved with databases?
Yes.
Okay. So, well, anybody who's involved with databases in any which way, they totally understand that there are very many different ways, or the data in the database is constantly moving. So people are accessing the data either from within the company or from outside the company. And if somebody has any malicious intent or is trying to hack to the data, it could be from outside or inside. But the point I wanted to make here was that if you are monitoring folks who are outside the company, or just trying to protect on the perimeter, the requirement is quite different than monitoring internal users. Because internal users, as we know, already have access to the systems. And the compliance officers, when they come and tell you that I want to monitor the internal users, they're talking about the DBA himself, because he's the highly privileged user in the environment. So the requirements are different. It's not enough. It may be enough on the outside to look for SQL injection attacks, dictionary attacks, brute force attacks. Those are very simple to detect also. Those are not hard to detect. But it's very hard to detect internal users doing irregular things because they have access to the system. So one has to focus on the content. If you don't understand what he's looking at and the security implication of that particular action, it's going to be very hard to be able to monitor the critical events, because you get a lot of noise in the environment. And we all know the statistics. 80% of the data gets compromised by internal users. And just the other day I was reading a report, it was from Symantec, and especially when employees are leaving, there's a 46% of the people take some data with them. So either they take employee lists or some kind of information from within the company that might fall under the sensitive umbrella. 46% of employees do that. Okay. So something or the other goes out of the company. And so we get use cases today from corporations that say, we want to monitor an employee who has given termination notice. So we start seeing use cases like that. Okay. So it is actually quite critical to monitor internal users. Statistics say 80%, but I just took all the different kinds of database attacks and put them on one slide because we start building. Hi. I'm Mehlam Shakir.
Nice to meet you.
Just put all the database attacks in these 4 high-level categories: hacking, malicious intent, inappropriate access, and user error. And as you can see, that there are very many different kinds of attacks. We are all quite familiar with this part, so I'm going to jump on. I'm going to spend most of the time today showing you what are the possibilities for auditing MySQL without using the query log, without using the binary log, without using the error log. Because number one, that doesn't give you a whole lot of good information.
And number 2, somebody can change them.
Exactly. So it has to be tamper-proof and so many things. There are so many requirements, once you get into a real-world environment. Now, the first thing that we find when we walk into the environment is that who's tasked with the security of the database? So many DBAs will say, oh, we are the ones who are tasked with database security. But what we are now finding in the field is that the internal auditors and external auditors don't want the DBAs to be part of the security of the database, because that violates the first principle of segregation of duties, right? So the security of the database has to be managed by somebody else, not the DBA himself. So typically it falls under the umbrella of the security group. And the security group has no idea what a database is. They just know that it stores some data and that's it. So first of all, we had to go back and make the information in a form that they can understand very readily in their language. So what they understand is, okay, there is a human resources server. It has some critical data. And if you can show it to them in this format, that here's the HR server, an account was added in the HR server. Or there was a failed login attempt on the HR server. Or there was a failed database backup. So they start getting and seeing alarms in a way that they can understand, everybody can understand, auditors can understand, people who don't know the databases can understand. And then they should be able to drill down. Because at the end of the day, if you're getting events, you have to be able to tell who, what, when, where, kind of thing, right? So the ability to click on, an event and be able to say, oh, this was the user. So ArcServe is my user whose database backup failed. Okay? So that generated that alarm. And then the ability to go back and see exactly what happened. Why did the backup fail, or what was the command issued? Because that once a person starts looking at it, is able to baseline and able to detect anomalies. So here, we say backup table employee to C drive, and immediately it could raise a red flag saying, why is he backing up to C drive? Because arcserve is an ID that should be used by our automated system. It should be going to tape. Why is it going to there? So somebody used that ID and who has the credentials and is now taking a backup on the C drive. Right? And then, even once you get a little more sophisticated, then it starts going into the details where companies can start putting in policies where they're saying, okay, I have critical information in these X tables, these different tables. And I want to create a policy where nobody should be doing a table scan on that table. Nobody should be selecting all the rows. Only the application should be connecting to it, and it never returns more than 20 rows at a time. So you can start getting a little more sophisticated, but every single time you want to be able to put it at a very high level, nicely normalized alarm groups, and be able to then drill down and say who are the users who triggered off these significant events, and what is exactly that they were trying to do. So any significant event related to the database, you may definitely want to report on that. And significant event is even a log on and a log off on a database. It's a significant event. But then there are many other events, especially for the security group, which need to have a rapid response, like a real-time response. And if there's a repeat logon failures against a database, followed by a successful logon from the same IP or the same user, that could probably signify that he was trying to break in, and he did succeed. So now that warrants somebody waking up in the night. Right? So those kind of things warrant a real-time action against the database. Outright policy violations, that somebody is not supposed to do a table scan on the credit data table, and they did it. Outright policy scan, it needs a real-time alert. Things of that nature, right?
So I have a question. Just to back up a minute, do you have agents that look for certain patterns and wrap critical areas of code to feed to respond back?
Yes, we have agents, and I'll get into the architecture of the product a little bit. But first, I wanted to build a case around auditing and seeing what are the possibilities. These are the things that you want to do. Now, let's see how can we do it. Okay. But yes, we do have agents. We have host-based agents and we have network agents. So we can do some monitoring over the network and we can do some monitoring on the host. Mm-hmm. And you can use a combination of those depending on your policy setup. But we'll get into that definitely in more detail. So let's start building some business cases and see what are the things that people really ask for. What are the things that we will have to do as DBAs to be able to comply with the internal auditing requirements or with external auditors, or just from a security best practices perspective. So simple things, like when an account was added, we saw that, right? Account was added, deleted, or it was modified. You need to be able to capture that significant event and be able to report upon it. Or if the production database is modified during business hours, let's say. It's something that you may want to be notified or just reported upon. So let's start running some queries against a real MySQL database.
I'm confused by that second bullet because wouldn't that be a somewhat normal, maybe I'm just not understanding what you mean by modified. A production database is modified continually during business hours.
Well, it could be DDL type of changes.
Okay.
So why is
might
there
not
not
do
the usual
maintenance
CRUD
during
stuff.
business
like
hours.
I should clarify it a little more like maintenance kind of work that's happening in the production during business hours.
Okay.
But again, it depends from environment to environment. We as DBAs used to do a lot of work in production on a lot of critical systems. We're making changes, tweaking things. Oh, it's not working well. Let's change the configuration here. We try to make a change on the fly. Or outright violating policies, because one of the things we would end up doing is we would not have access to all the privileged IDs, and we would connect directly using our privileged IDs. In some cases, highly sensitive environments, just using that ID is a major policy violation, going to a production database. I want to try and show you more things in real time today. I have some little cheat sheet for SQL commands so I don't have to type them. I can just cut paste them.
Then make sure your demo works. Because then you're not like, oh, what was that thing again?
Okay. So let's connect. I have a 4.0 server. Okay. So there are certain commands that are just going to fail outright, but it will illustrate the concept.
Could you possibly make that font a little bigger?
Okay. The first thing I just did.
Can you make the font bigger?
Oh, yeah, let's do that. Let me see how that can happen.
Thank you.
For us old people who can't see.
For those of us who have more experience.
I could strain my eyes to see if it would be a little.
Well, I have a zoom option, but it's not working with the display. Let's see.
Okay, if you can't, that's fine.
Let me see if I can use this.
You could probably actually make your desktop a little
Right.
lower resolution. Make the desktop like 800 by
I-
600
I
resolution.
could probably do that. Let
It
me
might
see
mess
if that
everything
affects
up,
everything.
Which might cause some problem with project.
Well, yeah.
It
As I
might
said, it
cause-
might mess everything up, but who knows?
It might mess everything up, but let's give it one quick try.
Display.
There you go.
Just a little slow.
If we can figure out.
No, it went. Oh, that's as small as you can make it. Oh well.
Move.
Well, we tried.
Okay. Okay. Before something breaks. Okay. What I just did was I tried to log into MySQL as a root user, and I typed in a bad password, and immediately I got an alert saying, I'll point to it, failed super user login. From this IP address, and there's some more information about it. It actually, the rule that matched was username equal to root and message number equal to 1045. Because when you try to connect to MySQL, if that's going to fail, MySQL server is going to return a message saying 1045. So we made sense out of that message. So we looked not only at their inbound request, but it was important to look at the outbound response for that particular request and be able to say what really happened. Okay. Now just to let you know, we'll discuss the architecture a little more, but we're doing all this by watching the network and the network packets. So
Like
let's
a
do a few
sniffer?
more of these.
Like a sniffer?
Correct. So it is an advanced sniffer which goes down to the database layer protocols.
Is it more of a sniffer or more of like a proxy where it kind of intercepts the packets, reads them,
It's more of a
kind moves them-
sniffer than a
more of a
proxy. It
sniffer?
doesn't intercept it. So it is an intrusion detection type of system where it is not in line. You could put it in line, but as a DBA, I'm always skeptical of putting anything in line
Basically a network.
with my database.
It's a network tab.
Yes. So you can use a network tab. You can use. There are a lot of options that switches provide. It's called mirroring and port spanning, and it will replicate any database traffic onto any other port, and you typically connect your probe onto that port. That's how most of our clients use it. They use a span port or a mirror port.
So do you enable this on each subnet?
Well, it
Or
depends.
It depends on the topology.
It depends on the topology. So you could span entire VLANs, or you could span multiple VLANs onto one port, which may typically not be a great idea to span many VLANs because you could drop packets there.
Mhm.
But I will explain that a little more as well. You know how we do that. If I keep doing this, I'm sorry. Only reason I wanted to do this was I wanted to generate a few of these. So we got a bunch of these. Now, you're seeing them on the screen. I just had a tail over here. But I should have the ability to send these alerts out in real time as well. Now what I'm going to show over here,
So this is your application, right?
this is also our application Logcaster, the one that I talked about before. But the database application has the ability to actually take this data and send it to any kind of security information management system. So in this case it's sending to Logcaster, but you should be able to send it to anything. You should be able to send SNMP traps, whatnot. Planning to click on this one. I should be seeing some alerts over here. It looks something like this. So repeat super user logon failures. for root user in the database server. Okay. So I did a multiple failures, immediately send out an alert saying there are repeat super user login failures. Let's do a few other things on the screen. Now I have successful login. You know what I'll do? I'll keep putting some spaces here so that we can differentiate between the successes and the failures. Okay. So now I did a similar thing, but now I have a successful logon, and you're getting an alarm back saying successful logon. And now I'm connected you to the system. Now every action that I take on the system is going to get recorded. Now you have the ability to record a complete audit trail, every single thing done by every single user. This is how we set up the system by default, and there's a reason for that, because we don't, it's up to the person to go back and then say that, hey, this is repetitive activity, and I want to absolutely discard these kind of events coming from this application server. I don't need to save this. And you can do that.
Do you only record what user provides? What about database responses? Is it also are they also recorded?
Well, what we capture from the database response is the metadata. So if a query succeeded, we'll tell you that 20 rows were returned back by the query. If the query failed, we'll say what error message was sent back by the user, by the query. But we will not capture all the data that is returned back, okay? Because that would be a lot of data to save. But we try to bring it in collect the data to such an extent where you could almost replay and recreate the scenario. So if you were to restore the database back to a point in time, by looking at the queries that we have reconstructed back, you should be able to almost replay what really happened in your environment and be able to even validate the number of rows that were returned by that query.
Do you provide replay capabilities as well?
We don't provide a button which says replay from this point onwards, but that's somewhere that's our objective. That's where we want to get to. So the tool is not there yet. So let's say we were talking about some other commands, right? So let's say if I try to do create user. Now immediately I'm getting an alarm back saying that a user, if you see a user added the system. So that way, if the privileges were changing, anything that was happening in the system, we have the ability now to get a real-time notification. Now this can just go straight into your reporting system, or you could get a real-time alert. Okay. So I won't type all the things that I had in my query file. I'm sorry, I'm going flip-flop between these things. So visibility into data access was one of our cases that, when anything significant happens inside the database, we're going to record it. We're going to alert on it if it demands an alert. Okay. We even looked at this alert on repeat logon failures by a user, and alert on repeat access denied errors. Now that let me run a query against the table, which is going to give us some access denied. So that might be an interesting thing to watch. Now, why is that important to us? Access denied errors. Somebody's fishing for data. It's characteristic of SQL injection attack, things of that nature. So these kind of things can be detected if you're properly monitoring the query responses. You got multiple in so much time frame, and you can almost certainly say that it's a SQL injection attack in progress. And there are some fascinating things that we have done, because this data, once we start feeding into security information management systems, we are able to start correlating this information with the information that comes in from other security devices like an IDS, which is monitoring the web layer. So now we are able to actually say that there is an attack in progress on the front end. It is making its way to the back end. We are able to actually correlate. So we have demonstrated these kind of things in partnership with some SIM vendors. That how do we take and start correlating this information back? So from a security context, the data is extremely rich, especially if you can tell if these queries are failing.
What's the threshold typically for number of access failed attempts?
Pardon?
What's the threshold typically for number of access failed attempts before its importance gets raised?
Those are all things that you can. These are all configurable items. But it could be like 15 or 20 in a few minutes if it's a SQL injection kind of attack, and if it's especially if it's an automated attack. Let's say if it's a directory attack or if it's a brute force attack, then you're going to find a lot of these happening very quickly. If it's a user at his terminal just trying to guess a password, then he could try 3 times. If he's clever, then maybe go get some coffee and then again try 3 more times. But we should be able to catch those kind of things as well. So even if it doesn't warrant a real-time alert, you should be able to get a report saying that this user, from this IP address, made so many attempts at the end of the day. So that will be very important. You know what I'm going to do? I'm going to VPN straight from here because I'm having a little trouble going back and forth. That is better. So now I can go back for my query quickly. Okay. So I'm going to quit out of here. I'm going to log in as another user which doesn't have as much access to the system.
Yeah, you have to use dash u dash h dash p.
That's strange though. All the dashes disappeared. Can I cut paste?
Sometimes that happens with word processing things where they use smart quotes or smart hyphens so that it just doesn't show up. We didn't see that password.
So that was a security problem, right there.
Well, that's why this guy doesn't have good access, right? Because he does
Right.
things like
But
that.
now we're auditing, so we're okay. Okay, and let me. I'm attempting to show you all this in real time, but everything is running really slow. Let me see. You see this access denied error? You see this over here? When I did an insert into taxpayer, and it said, insert command denied to user Troy. Okay, and Penguin. Immediately I got an alert there saying that access denied, and I can see the exact query if you look at the query. You can see the exact query. Okay. We know which IPs, which server he's going against. He's going against the server on 15 on port number 3306. It's coming on from this IP address, so we know exactly where it's coming in from. Okay. Now this is just the alert file, which has only a few metrics. But if you look at our data file, we have 25 metrics. And in some protocols which are even richer, we can even tell the operating system users and things of that nature, which applications they're coming from. The MySQL protocol, unfortunately, is not very rich, so we cannot find certain things like what is the source application name, because all these things are useful. We create rules in many environments where a lot of people create policies like Excel is not allowed to connect to a production system. You shouldn't be using the Excel application. You should only be using PeopleSoft to connect to my PeopleSoft server. That's the only way the access should be. So they create data access policies. And when those policies are violated, but some casual user saying that, okay, I'll do my work at home, just connect to Excel, I'm a smart user, get the data back, it should be able to alert right away that there's an unauthorized application that is connecting to the system. So the source program metric is not available for MySQL, but many other metrics are. The OS user metric is not available, but the database user metric is available. So we still have a lot of information, and very rich information. So, I mean, you get the point that even things like this, like access denied, can be easily captured, and all this can be even done over the network without impacting MySQL at all. Okay. Okay. So let me jump back to the slides. This is another use case we get all the time. Is that our super users or our application users should only be connected from trusted networks and not from untrusted networks. So you should be able to create data access policies when user John's ID gets used from somewhere else, or user root connects from a system where he's not supposed to be connected, or from a untrusted network. That should be cause for an alarm. So the only reason I put up these slides was because I wanted to show you a few things live. Also wanted to help you, show you that these are the business cases that we get from the end users that who finally purchase a system and who want to get these kind of tools approved. They go in with very specific 4 or 5 use cases, inappropriate access. Let me demonstrate that. Hacking attempts. Let me demonstrate that. Here's one company that we work with very closely. The company is Career Education Corporation. It's based out of Chicago, and they have over 100,000 students, and they have campuses worldwide. So that is an environment in which a lot of hacking takes place. It's the nature of the students, right? And again, the case study was that the security group is now tasked to monitor the database system. They have no idea what to do. So the first thing we gave them is visibility into application access. The first slide that I showed you, where now it's translated into a language that they can understand. But very soon, they started adding use cases. Once they saw the power of what can be achieved. The next one was basically privilege abuse by staff. They were finding people who were granting all privileges to somebody else for convenience. He's my friend. Let me grant him all privileges. Or sometimes just it's simpler to do that. Grant all is much easier than So those kind of things, especially in certain critical production environments, maybe could later on be a big problem. People attempting to gain unauthorized access, students doing it all the time, trying to break into the systems all the time. Now they wanted to start knowing who's doing it, when they're doing it, how are they doing it. They want to know the trends, how all this is possible. SQL injection attempts, there were SQL injection attacks happening on the website, but they never had a clue as to what finally reached the database and what was actually breached. So that was the other thing.
When you say injection, you mean like storing SQL sentences in the database?
Pardon?
When you say SQL injection, you mean that like storing queries inside the database?
No. Let me explain to you what SQL injection is. SQL injection, most people are familiar with what SQL injection attack is? Okay. SQL injection attack is, you use a vulnerability in an application, in a web application typically, to get data from the database, which you are not supposed to be getting.
Right.
So for example, you put a union clause to a query and fool it to give you some more data.
But the query would be like you enter your username, and your username is quote or true. And then if they put it into a query, and your username is quote or true, then your username would be like, select where the password is that. Then it selects, true if, there's a row from this table where username equals quote or true, and then you end it with a quote, and then it goes back.
So
Somebody's building dynamic SQL.
Yeah, that's
Yes.
what it is.
When they shouldn't be.
Into the username.
And they're letting people
Or password, yeah.
put in information that they're using
Or
to
password.
build dynamic SQL, and they're not checking to make sure that what they're putting in there isn't something that will change the very nature of the query that they're building.
Right. But people do it all sorts of things. I mean, you can do it in a get query for an HTTP. We've actually had a quote unquote attack where somebody decided to log into their account, and they realized that if they viewed the source, they could see the URL, and so it had their user ID in it, and I think a while ago it had their session ID. So what they would do is they would go collect usernames and then use our webmail function to compose mail, but they would do it very quickly because it's like, well, I have this username. All I have to do is compose mail to it. So you just look. I mean, how easy is it to get a page of usernames from a networking site? You just do some kind of a search. You get a page of usernames, and then you just hit your script to go, and here's my service that I'm offering for pay, and you email 5,000 people in 10 minutes because you could use a get variable. And that's not even necessarily SQL injection, but you can do that if you're, yeah. All the blogs and stuff that say, where the, article number 1, article ID equals 1. Well, if you're not checking that that's a number, and you just say select the title from the thing where the article equals 1.
And many, you probably heard many times in news that, certain websites, they get defaced. So there's some attacker. And many times what happens is basically they succeed in a SQL injection attack. They got more data out. And finally the output from that is translating back into the web page looking different. So they're showing some other results which came out from their systems from somewhere. But one of the other use cases that's starting to come up now is forensics analysis. It's interesting that a lot of security officers are now telling us that we need assurance from management. So we are better off spending a penny for monitoring every query or every important access to an important table and assure the management that by reporting upon it that indeed the data was accessed appropriately, and if there was a breach, we'll be able to go back and tell exactly what happened, may be able to reproduce that environment. And then how are you going to do that? How are you going to be able to reproduce what happened in the database? The only time you can do that is when you are able to tell exactly which queries hit the database and what was the outcome of those queries, whether they succeeded or whether they failed. So if a SQL injection attack was taking place against a very important table, only if you knew that there are inbound queries, and there are a lot of tools that will tell you what query is coming to the server, but they're not intelligent enough to tell you whether those queries are succeeding or failing, because it takes a lot more work to be able to figure that out. The response codes back from the server. Then what good is that? Because will you be reporting back to all your customers saying that your data was breached? Because the attacks may not even have succeeded. Because the number of attacks that take place and the ones that succeed, the ratio of the ones that succeed is very small compared to the attacks that take place. So it's very important to know, exactly what got breached. So if the query succeeded, it's important to know that 50 rows were returned back. So you probably need to report to only 50 customers, that your data was breached, something of that nature. Right? So how do we do it? How does our system do it? Now this is a typical environment, where you have a client, you have an application server, and then you have a database cluster. So the queries, if you turn on native auditing, now in case of MySQL, what are the options that we have for native auditing? We only have query logging, we have error logging, and we have the binary logger, which is really meant for application and things of that nature, right? But even if MySQL in their next version, if they came up with some fancy auditing function, the problem you're going to face is unacceptable performance.
Yeah. Well, and the fact that it's not independent, right?
And
If I'm, and that's the big thing. Everyone's like, well, Oracle has, or SQL Server has, SP audit, but then if I'm doing it, I have control over it, so I could, let me go delete that, and it logs to the table itself, and...
You took my fourth point.
Okay.
Sure.
Sorry.
So the fourth point here was, cannot segregate security duties from the DBA. So if you're going to turn on auditing, like you do in Oracle, let Oracle write it into the tables, then the DBA nicely goes and deletes those rows from the table. How good is that? Right? So segregation of security duties from the DBAs that is why it's become very critical. And if you have native auditing functions, it's more likely than not that the DBA is the one who's going to be tasked with the security function, and then the compliance officer is, you are basically not going to pass an audit with that. Again, these are the real world problems, right? No management and reporting. Most of the vendors out there, Sybase, DB2, the others, Oracle Volt, which starts at 50,000 per processor, which they have just released like a week ago. 50,000 per processor, okay, is what they charge. Is the only one so far which has some form of reporting. None of the other vendors. You can turn on tracing, but you cannot report upon the data. And it's your headache when the tables fill up. Okay? So they leave the whole thing up to you. And again, they will never support a competing tool. So if you have a heterogeneous environment, then it's your problem. Right? So nobody gives you the native auditing. That's why these are the 4 major problems. Okay? But unacceptable performance was the biggest problem that we used to encounter because it is tracing inside the database. A lot of people argue that we are going to build a lot of good security in our application and avoid it from being compromised. No matter how strong your roles are in your application, you always have these backdoors because the DBA comes in directly to the system. He doesn't come in via the application. The hacker never comes in through the application. So you have to be able to monitor this layer right here at the database layer, because otherwise you're going to have all these people bypassing the application server. So this is one of the objections we get in the field. That people say, oh, we have PeopleSoft, we have SAP, these are enterprise systems, they have fantastic auditing. And then when we ask them, what about the backdoors? They say, is there a need to monitor the backdoors? A lot of people, I call them the bravehearts, they've tried to use intrusion detection systems to monitor databases. And the reason they do that is because they know about signatures that come with Snort. Snort is a very popular intrusion detection program. But the problem is that Snorts of the world are not session aware. So they cannot, once user John logs into the system, they cannot tell you. They are only looking everything as a single event. They do very minimal correlation. And almost certainly, they will not give you an audit trail. Okay? And they will
Not giving
an audit trail. An audit trail.
audit track?
Trail,
Audit.
an audit trail, so you can't
Oh,
say
okay.
Shiri logged in and then did that and then did that and then
Yes,
did
yeah.
that. They
It's
just
an
know
exact
Shiri
audit.
logged in and 2 seconds later Mel logged in and 2
So
seconds
you
later
can
Jacob logged in.
track the actions from specific user.
Exactly. So it becomes, especially in case of applications, it's very important to track the sessions. In case of a firewall, that works fine. If you're looking for a buffer overflow attack against your database system, where you're just looking for specific signatures, it's fine. So the database monitoring products will complement Snorts of the world, but don't try to use Snort of the world as your security product for monitoring databases, because they were not built to do that. They were, they just do random pattern matching against. I won't say random, but they look for specific signatures in the packets, and that's all they do. So all these 3 approaches have very limited value if you take them individually. So what we did was we came up with our solution, keeping in mind that impact on production databases should be minimal or none at all. And if you want the impact to be 0, then you cannot have a monitoring system which is running inside the database. Especially with the auditing requirement to the level at which it is now, where you are required to monitor selects going against the sensitive tables, and there could be hundreds and hundreds of them. You could be impacting the performance a lot. Okay, as long as you restrict it to just DDL activity, then probably it's under limits. But once you go beyond DDLs to start monitoring selects, then really you are going to take a real big performance hit. My experience with Sybase is 40 to 45%. Once you turn on high level of auditing, again, it's going to write straight inside the tables in the same database that you're monitoring.
And you're going to run out of table space and all that kind of
those
stuff
other
with
issues,
Sybase,
all
yeah.
those other issues. So there's no management and no reporting. Okay? So that's the other headache that you'll bring for yourself. So the other important requirement was a complete user session audit trail. You should be able to tell that John logged in from so-and-so machine. He ran these 21 queries in this exact order. Only 5 of them succeeded and the other 16 failed. And then he logged out. So you should be able to give that complete report. And it should be a plug and play kind of a system where there should be, for it to succeed in the real world, you cannot make a lot of configuration changes in the database or in the application. So it has to be more or less plug and play. So that is why we came up with a network-based monitoring tool, because the concept lends itself to no impact. If you really try to understand the packets that are flowing back and forth at the application layer, you can indeed construct an audit trail, and that is what I will show you in a little while. Now you've seen the specific events, the single events, but you're not seeing the audit trail. Here's John connecting, here's the 20 things he did, and then he logged out. But yes, you can indeed actually create a user session trail. And the reason why it had to be plug and play was because if the security officer is the one who's going to be monitoring the database, and what could be easier than just taking an appliance and putting on the network, and he starts, he just asks the DBA which database should I monitor, the business groups, which database he's supposed to monitor, and just putting those IP addresses and he starts monitoring them. It has to be as simple as that. And the reason I say that is because typically we run into three major stakeholders when we try to deploy our solution: the security team, the DBA, and the compliance officers. There are all these three people, and the DBA usually has the mindset that if it's going to audit the system and it's not going to affect the performance, then I'm cool. And that's exactly the way I would treat it as when I was a DBA. That as long as it's not going to affect the performance of my system and it's going to do what it's supposed to do, I'm cool with it. Okay? Other than that, he doesn't want anything to do with it because he already has too much work to do anyway. The security officer has no way around it because he's the one who's tasked to monitor the systems. So,
what do you do about traffic? What do you do about local access, right?
Okay.
Directly on a machine.
Okay.
It's not going through the network.
absolutely, and that's the point. Now, if I'm logged on directly onto the system and it's not over the network, then what are we going to do? What is the way out? You have to monitor on the host. Right? So now, the network agent is not enough. Now we have to put a host-based agent. Now, we always recommend to customers that you should have a policy in place where, first of all, the duties must be separated between a system administrator and a database administrator. That is anyway the first law of segregation of duties for compliance. Okay? If the DBA gets onto the machine itself, then there are many ways to compromise the database if he has access to the operating system on which the database resides, and the security team needs to be aware of that. A lot of people in a lot of environments, they're taking away the host-based access from DBAs. When I was at Goldman for many years, they started taking away access from us, the ability to log onto the machines. Because once you had installed the database, almost always, the vendor, DBMS vendor provides utilities for you to do everything remotely. And the time that you need access to those machines is if there's an emergency problem or there's an emergency bug fix that is required, and that can be handled through emergency accounts. So you can always put a host-based agent, but we always try to talk people into creating better security policies for themselves. And if there's no way around it, in some real-world environments there may be no way around it because system administrator is the DBA. In that case, but he still needs to prove to somebody else that he's monitoring himself, then you can put a host-based agent. And here's how we would do it for the host-based agent. Now, our agents were typically built to monitor TCP/IP traffic that is going into the database. And if it's local access in case of MySQL, MySQL can use Unix sockets, not just TCP sockets, but Unix sockets, right? Today, our tool does not support Unix sockets. So that would become a backdoor to our application. So even if we had an agent on the box, and if there was local activity, which is not going on the network, it can go via Unix sockets, and we would not be able to see that. But a simple configuration change in the .my.cnf file, you can make it go over TCP sockets instead of Unix sockets. All you do is, instead of saying localhost, you put 127.0.0.1, and it starts using TCP sockets instead of Unix sockets. So a simple configuration change, you can monitor exactly the same way you monitor the network right on the host itself. Okay? And one thing, what we did over here was to keep the performance impact at a minimum. What we proposed was a solution that anything that you can see over the network must be monitored over the network, and only what cannot be monitored over the network, which is only on the local host. And if you really need to do that, monitor that, then that agent should only be monitoring that stuff and nothing else. So, on each of the host systems, there is something called a loopback adapter. Is everybody familiar with the loopback adapter?
Yes.
Loopback, right? So what the loopback adapter does is, if you want to use a networking of two applications which are on the same box, you can use TCP/IP exactly the same way, but it doesn't really go over the network. It behaves. It almost fools you into thinking that it's going to go over the network, but the system uses something called a loopback adapter to send it back to itself. But it uses the same concept. You can take those applications and put them on separate boxes, and they'll just be working fine, or you put them in the same box and just work fine. So the operating systems usually handle that loopback for you. And one thing that we provided with our agent was, you can configure it to just monitor loopback activity, which means that all the network activity was visible over the network by the network agent anyway. So why take that overhead in that agent to monitor all the activity coming to this box? Let the guy on the network monitor everything that's coming over the network, and anything that was not going over the network, just look at the loopback adapter and figure out everything that's just local to that system. Okay? So that's how we handle the loopback activity. So agents are available, but we don't recommend them.
So loopback is essentially host. All host actions go through loopback, right?
Correct, correct. But you will have to still make one little configuration change in MySQL to make sure that it goes via loopback, because it can go via Unix sockets. And we don't support Unix sockets today, but we are planning to support Unix sockets also.
I may have missed something when the crowd was walking by outside there. You said that because of a configuration thing back a couple of minutes ago, you could reset I think it was the local host, the 127.0.0.0. Is that a configuration file on the server that you're talking about?
Yeah.
What would prevent then a DBA? Would that
Well,
be
that can be
monitored?
controlled by root. That can be controlled by root user. So that is the exactly the problem I wanted to
I'm trying to
highlight.
figure out, if I'm a DBA and I can get to that box, why can't I change that configuration and screw you
Well, but
royally?
if somebody else owns that file, so that's why once the DBA is on the system, if you have given him access, then you have to make sure that his credentials are limited to the database directories and nothing else.
Okay.
Or some critical files like that, should be owned by somebody else,
Outside
like root.
the package, yeah.
But when you bind to, it's using bind address, right, to 127.0.0.1 or something. When you do that, I mean, you're changing status variables. So I don't know how this works for custom things or if you have it built in, but can't you say alert me when a status variable changes? Whether it's set foreign key checks to off or or when you change the bind address, or even alert me when the database is down, because you would have to restart it. For bind address, I think you have to restart it. For other things, you may not have to, but you may still want to do that.
And we do capture variables as well.
Right.
So even if you do a show variables,
Yeah.
we still capture that event as well.
Right. So that would catch that. If you put the alert to, if this variable changes, alert me, that would catch that, right?
Yes. Indeed, you can even monitor the changes to the variables.
How would that be implemented? A callback function, or does it poll the variable? How would it actually?
No, well, if it's a command to set something, and if it's going, most of the MySQL commands, all the administration is through SQL commands. So it's like a regular command that you type on the console itself, let's say,
Right.
or somewhere outside. We are capturing that as a command that's going to MySQL server. That's how we are capturing it.
So can you capture variables that are changed in like a configuration file and restart, or no?
Well, if you're going to do a restart, yes. Now, if you're asking that if something is changed in the file, will I be able to tell what changed in the file? Here's what you can do. We have other agents as well, like for example, Logcaster, which monitors operating system activity. So what we recommend is that if you're going to give the DBA host-based access, then you have to turn on auditing even on the operating system level. Because if you don't, then how are you going to monitor the file changes, right? Like the system configuration files. So now Linux, Windows, any operating system you can think of already provides auditing for files as well. So you have to do the due diligence in terms of taking care that all these bases are going to be covered if the DBA is going to have local access to the host. What is easier? To not give them local access to the host. Because there's almost everything that can be done using administrative tools from not being on the box, other than installing the software itself.
So you consider
Because they could still
install.
break in.
Pardon?
The whole point of this is an intruder could still break in, so you have to have something on there in case an intruder does break in.
No, security's perfect.
Correct.
How do you keep somebody from filling the process?
Well, if somebody
How do
issues
you
a
keep someone from
command,
unplugging the box? I mean,
Oh, yeah.
this won't do that either, right?
but that's why you need, this is complementary security. That's the point I want to make. That, database security, there's operating system security, there's network security. There are all the securities. And that is why the other important thing is that when the security officer gets a tool like this, he wants to feed this information back into his security information management framework for this very reason. That he now needs to start correlating events related to certain IP addresses and be able to start putting the puzzle together as to what is happening, why,
See the patterns.
yeah, see the patterns. So let me show you a little bit of how Informant works, how do you configure it, and how do you set it up. The first thing when you get our appliance is you will do some basic configuration. And the first part of the configuration is to do a monitoring setup. So you come in and say, these are my IP addresses. These are the systems that I want to monitor. Sybase, DB2, Oracle, MySQL, Microsoft SQL Server. So we support all kinds of DBMSs today. Okay, so if you have a heterogeneous environment, you will need a tool like this, because like I told you, the problem, every version of every provided by every database vendor is different. So if you're going to, you will have to normalize in a similar format, especially if you're going to create reports for your auditors, because the auditors don't really care what is DB2 and MySQL and Sybase. All they need is a report for their servers that they're responsible for, which fall under the SOX umbrella, and that's all they care about. So you will need to be able to report across heterogeneous environments and across different versions and platforms. Okay? So here, when you add a new monitoring rule, essentially what you provide is an IP address and port number. So if you were to monitor another MySQL server, what you would come in and do is you would say, here I have a MySQL server, and this is my server name, and here's the IP that it is on, and it's on the default port 3306. Now once you do this and you submit it, that's basically what you had to do to set up monitoring for this new MySQL server in your environment, right? So we just added a rule right at the bottom, for your server on this IP and this port. And the reason we provide IP and port is because you have to be able to, if you're monitoring over the network, how does the packet get to its destination? By IP and port. Okay? So that's how we trap all the packets going back to the destination server instance. So here we are saying that this appliance has been set up to monitor all these servers. And it's going to normalize data across all these servers exactly the same way. Okay? It's going to not only monitor the inbound queries, it's also going to monitor the outbound responses from these servers. Okay? The next thing, once you set it up, you need to create some rules and policies. Okay? So here, let me delete all the rules for you first. And let's create some rules. So let's say, the first thing that we had seen in the slide was all significant events inside the database must be captured. Log on, log off, DDL changes, privilege escalation, things of that nature, access denied errors. All these rules can be out of the box. There's no reason that you would have to sit and build every single rule. The only rules that you would have to build is what are the tables that are critical to you in the system that you want to specifically monitor and report upon for your auditors. So here is my table that I need to audit. Other than that, you're supposed to capture there should be a whole list of rules already available for you. So in our system, you say build rules, and it creates the active rule set. Did I lose connection? We'll reconnect from here. Sorry, it's taking a little longer. I was expecting things to work a little faster in Boston, in Cambridge, but there'll be a really high-speed system over here. But I guess I'm limited by my Verizon card.
What about Windows like named piped in shared memory? That's the Windows local way to connect. It's the same thing as sockets, or?
It's the same thing as sockets. For MS SQL Server environments today, we don't support name pipes, but we are going to. Almost nobody uses it that we have asked in every single production environment we walked to and said, do you use name pipes? And they said, no. So we tell them to make one configuration change in their system so that name pipes is blocked.
So they can't use it, yeah.
Right. So nobody can use it. So we
And
have
then
to
it would
make
probably be easy to check for someone connecting from localhost.
Yeah.
So you could say if there's no, even when you do have an agent, you could say if there's no registered host agent and somebody tries to log in from localhost, you could say, hey, wait, there's an error because you're logging in, we're not monitoring it.
Okay, yep. We'll try to connect from here.
You have Linux and Windows simultaneously?
No, what happened was I had a remote desktop and I had set everything up with all the windows.
Okay.
And that remote desktop is working so slowly that I am connecting now directly through VPN. That's faster, I think, instead of going to the remote desktop. Okay. So what I had done was I had built the rules, and I want to show you a few rules. So what do they look like? Okay. So a default set of rules from basic rule builder were built. Now let's walk through a few rules. Like an audit table was accessed. Now what does this rule really say? And look in the query text. Look for these three table names. If you're familiar with regular expressions, it's a simple regular expression saying if the query text contains the word SSN underscore table or username underscore main or credit underscore data, then match for these tables if it's in the query text. Okay. Let's look at the access denied error. How did we figure out that an access was denied to that particular user accessing that particular object? Because we saw these particular message numbers going back associated with that query, which says column access denied, table access denied. These are the different errors that MySQL throws back, and we are able to track for this query. This was the response the query got. So these rules, we already built out of the box. Access denied. Well, let's look at some others. Like a suspicious command was issued. So for example, we were looking for a simple thing like saying grant all. Why is somebody granting all privileges to somebody? So it's a significant event that it should be actually captured in your reporting system at least, right? Or if there's a system table change, if you look at this, you're saying the database name is equal to MySQL, which stores all the all the important information, and inside, if somebody's doing an insert or update or delete in that MySQL database, then we will consider it as a system table change. Okay.
So did you parse out the verb and the objects in the actual query, like table, salary was accessed or table payroll was accessed? Or
Yes, you
do
can
have to
match
do
it
it,
as
or do you
anything.
have to do it? But do you have to write it as a regular expression to do that match? You
The
can't
regular-
just specifically write a table equals this or table equals that. You'd have to write it.
By you, do you mean the
The person writing these policies.
the person
the
writing
person
the
writing these
policies.
filter rules.
let's write one of these policies. Like you want to access a specific, you want to monitor a specific table, right?
Yeah, and I want to know that it's the table name, not some column name that just happens to have the same. Regular expression just lets me know someplace that in this text,
In this whole query text. So you're
I want
saying
to
that
specifically know that it's a table in this particular schema, or it's this column in that particular table. Like
And that's a very good
the
question.
salary column in the payroll table,
Okay.
as opposed to just finding the word salary randomly inside of the query string.
Right.
And that's what we're doing now. That it's nice to match against the query text,
Right,
but if you want to match directly against the table, so you should be able to say table name equal to this,
Right.
instead of query text equal to this, right?
Exactly.
So in upcoming version, basically in our next version, what we're doing is we're taking the query text and we're breaking it up
Parse it into
command
into
type
objects and
objects
objects
inside.
and verbs.
So you can write our rule engine. You'll be able to match against exactly against table names. You don't have to match against query text anymore. There was another reason for us to do that as well, because if you want to do good baselining, then what does a user typically do? Like user John, he always does inserts, updates against this particular table. And if he does something else to that table, he does an alter table, suddenly that should show up as an anomaly for that user, because he never does that. He's never, he's an application user, he only does inserts and updates through his application, and suddenly, how is that user doing an alter?
So you created a user profile?
So we start, the reason we are doing it mainly is to create better user profiles.
Right, and you can easily distinguish between DML versus DDL versus security either without doing that kind of parsing.
Correct. Correct.
well, yeah, and
So-
something like your database, because you have in this version you can do the database name. Is that just what the current database is set to? Because MySQL has that problem with replication. When you say replicate this database, what it means is replicate the commands when you're in that database. So if you actually change something and use the dot notation, like if you're in
Right.
the test database and you change the main
That's the thing
database,
about
it won't do that,
expression.
right? So is that, yeah, that's another reason to change it if that database name, which probably is just the active database,
Mhm.
then it's better to change it to that. That way if somebody tries to get around it using the dot notation for database dot table,
Right,
then.
right.
So you know,
Because you have to write the regular expression now to look for that. That's how that was one of the expressions, we're looking for the MySQL database. So if anybody said MySQL dot user table, or he's done use MySQL database and then just done, update user, both of those attempts we should be able to capture them. Right? So you basically would need two rules, where database name equal to this, or he's actually in another database and he's affecting another database by using the qualifiers, the database name as a qualifier. You're clear on that, right? So we should be able to capture both those.
I have a question. If I have a replicate database, right, what happens is, which means I have to monitoring on the both at the same time?
Yes.
So if
Because
I have
what is your
something-
replicated database for? Are users connecting to it? Is your reporting system running on it? People are doing things to that the same way, right?
Mhm.
So if you have sensitive data, now your data is basically in two places, so now we have to monitor both of them. Now you may choose not to monitor the replication part of it. What part is being replicated from database 1 to database 2, because that is done by the system. You can choose not to monitor that part.
But if I use a replication, one for report, one for production, right, how can I configure, different? For example, right, I have a replication database, one for production data, keep writing, on the other side, right, another database just for reading.
Right.
So how can I configure this rule? I want just allow you to this select statement on my report database, and on the other side, I just allow people to write only. Not let you to read.
you have to
Except for the
follow.
DBA who gets to change that.
Right.
Which you have to watch
Except-
also.
right.
Now these rules, you can include a lot of different metrics. So here, it's not only by query text. I will give you an example of the different things. You saw message numbers, but then you can use things like client IP addresses, server IP
Oh, okay.
addresses. There's so many more
Specific,
metrics
okay.
that I've not shown you yet. That there
Okay.
are at least another 25 metrics that you can use to create very
Okay.
specific rules. Let's go down the list and see, maybe there are a few.
Well, is there like a pull-down list with everything where you can, because when you create them, there must be like a pull-down list with all the ones that you can choose, right?
Select.
Yes. What is it trying to show you? Yeah, there are a few other things that I just wanted to show you here real quick. These other metrics over here, like for example, response time. So the query response time is greater than 10, which means greater than 10 seconds. Server response time, which means that the query connected to the server did not respond back even with the first packet for that much time. Okay? So it's different from the response time, which is the end-to-end response time, where you send the query and it returns 5 minutes of data. So it takes time to send this 5 minutes of data. So that was the end-to-end response time, and then there was a server response time, then there's a network response time. The return rows, it's saying that we had seen in the very first slide that if somebody does a select star from a credit data table, and if that is going to return more than 1,000 rows, that could be your policy. That if it returns more than 1,000 rows from this table, an alarm or a significant event. So you could be monitoring on all these kind of things. And if you notice over here, we're looking at return rows and data in and data out and message numbers and packets in and packets out. And so there are a lot of other metrics, and I will show you, what are the other metrics that are available. Okay? So even things like this, like deadlock detector. You could start monitoring all this stuff and response times, your query slowing down all over the network. Okay? Because there's so much information already available on the network itself. You don't have to ask the database those questions. In fact, presently our tool doesn't talk to the database at all. So it doesn't. You don't have to connect to the database for any reason at all. It's completely. They don't even know about each other.
Now-
Other than the fact that you asked it to monitor certain IP and port number.
How does it do things like if you're writing application code, if you're changing your database, you don't necessarily type, the code doesn't do use database. It uses the underlying API, or it
But
might
it
use
still
that.
translates back into the commands that MySQL understands. Because MySQL has a protocol. If you're connecting with a network, MySQL database engine understands a certain protocol. So if you say anything beyond that protocol, MySQL is going to say, I don't understand what you're saying.
Right.
So whatever language you write in, finally, when you connect to MySQL, it's translating back into its same protocol.
So if something performed on the server, like store procedure or something which has no access to the network, you are going to catch it up through the loopback?
Well, here's the thing. Like, let's say if you have a store procedure execution, which is also happening on the network, let's say. You know, you said exec store procedure, okay? So you saw the exec store procedure. Now, if that store procedure calls another store procedure, now that is happening completely within the system, right?
Right.
Because now nobody knows about that except the database. What we would see over the network, we could not even see over the host. Nobody knows about that stored procedure called the second stored procedure other than the database. So
Right.
nobody knows about it. So you will not know the execution of the second stored procedure unless you did a dependency and you, on the first procedure, you know, that if you call the first procedure, it's going to call the second procedure also.
Yeah.
So we will see the execution of the parent stored procedure and we will show you the response time, all the metrics associated with that. But if you want to go down into the details, and a similar example would be trigger, right?
Yeah,
Trigger, who knows about the
exactly.
trigger?
Yeah.
Other than the database
Which
itself.
calls store procedure.
Right. So nobody knows about the trigger other than the database server itself.
But that's why you get the create statements, right? When somebody creates a
Oh,
trigger,
you-
Exactly, exactly.
you
But you
log
can
it. When someone
create
creates
statements
it-
like few months ago, and it's difficult to reconnect them. You can, yeah, what's happened few months ago, database still could be
You mean
alive.
you're saying, like, let's say you get this monitoring system and put it on, it doesn't
Right,
monitor
right.
everything there. Well, you
And I
know,
never called it for a month.
yeah.
Unless you have the internal database monitoring on, you won't know that.
Right.
You know,
Yeah.
within-
Almost
within
all the
Oracle,
environments that we
every
walked
time
into,
someone of those,
they would
throw-
initially come and say that, you know, we want to monitor triggers also. At the end, they would drop that requirement. And the reason for that is the create trigger was a very important event.
Yeah.
So as long as they knew that a trigger was created and that was not a Trojan, it was a real trigger.
You can track by the name.
Right. So
Right,
when
you
the
can track
create
back
trigger
with altered
happened,
by-
you know for sure that the create trigger happened and you validated that this trigger that went in production is a safe trigger. Okay? Now you know that the trigger doesn't insert, update, or delete to certain tables. You will not know the execution of every trigger, but that is again a system generated command. Right?
Does the number of rows returned, does that include like stored procedure? Like if you have a stored procedure that changes one row and then calls another one that changes another row, do you get that it's 2 rows that have been changed, even though you only know
We are
about the
only
one
tracking-
call?
We are only tracking the parent. We will not be able to track anything that is happening within.
Okay.
Right? So now, if in some environments that we walk into and somebody says that, okay, well, the trigger is also important in this case, then they have to use some form of native auditing. And typically you can do that, you know, the trigger can be made to write something in another table, basically saying that I fired,
Right.
right? And that is the only way around it. That if it is very important, we recommend that it can be done on a per case basis, like for those specific tables only.
I'm also thinking about UDFs and schedule events.
Right.
That is a kind of Pandora box in some way. You still have to install this UDF.
Well, when you
You-
install
so
any of these
you-
things,
you
when you
can
create
see
them, you are
that,
going to see
definitely.
them. Because that is a DDL, right, change. So,
Well, UDFs aren't. UDFs are compilation, right? You compile it into the thing and...
Oh, you compile it outside the database in
Right.
some way. But when you install it, you can catch up that that command, create function. Yeah.
right. So once you do the create or alters, those will get caught right there.
And also calling the select statement. It's more difficult with a scheduled event, which are triggers and you don't see who called them.
Yeah.
Okay.
So the database is the best option, and MySQL. Go ahead.
I have 2 questions, really. The devious criminal part of my head is feeding the first one. If I was a disgruntled employee, and I knew that in some number of months I was leaving, and we were running MySQL 5, I could build a stored procedure which does absolute havoc to the database, and I just store it in there, and then you guys come along and put in the security system, and then I leave. in order to keep my code from executing, do you in fact encourage a complete examination of all the metadata-based tables in the MySQL database itself? First of all, to make sure that stuff is clean. Second of all, I think you lost the connection before. I wish I knew your name. I'm sorry.
Lorraine, yeah.
What is it?
Lorraine?
Lorraine asked about regular expressions. I may have missed it, but I don't think we covered it. When you actually create these rules, do you actually physically have to type the regular expression, or do you
Let me
use
show
a
you actually.
user
Let's add a new
interface?
rule.
Did you get that answered? I didn't hear it. I didn't
No.
I was under the impression that some of these were
No, we
canned,
clicked on this.
and then you edit them.
And I
Okay.
never,
They were
we never actually went into the
assisted.
details. So I selected that radio button and I said clone it and let's change the rule.
Right.
But I never really showed you how to do that.
Okay.
So you
Some
can
of
clone
these were-
rules.
Some of these
Okay.
were.
But this is the actual interface. That's what we're talking about.
Yeah.
It's
Yes.
not. You don't have another additional GUI section which allows you just in English language to say monitor the employee table dot salary, and it translates it into a
No,
regular
no,
expression.
not right now.
Okay.
But that is another thing that we're working on.
Okay.
An expression builder, which makes it a little
Yeah.
simple. So
Okay.
right now, what we do is, for things that you would need rules for, we give you a clone option. So for example, let's say if you wanted to monitor you wanted to audit another table,
Yeah.
other than the 3 sample ones that we provided, you could go back and you could say, my table here. Now this is basically the syntax, okay?
Yeah.
That any of the allowed metrics you can match against. You can do logical expression matches, regular expression matches. You can do and or nots, and you can use a combination of that with parentheses. So it can be fairly complex, but you have to follow the rules of the rule expression. Okay. So if it gets complicated, then you can use one of our rules that we have provided and just go and edit those rules right there. Okay. But for example, the single quotes, the double quotes, those double quotes are required. This will throw an exception saying that it did not follow the syntax, because it has to follow certain syntax. But it's not all that hard, because I said query text rejects exp. If you just said rejects xp, that is a syntax error, because that is not a recognized keyword for us, for our parser.
Okay, what about the clean metadata issue that I first asked about?
What's the clean metadata issue?
That's like what Jacob asked about. If you make something that's insecure before you put the monitoring software on.
Do you guys look at the overall structure in the database first to make sure it's
Well,
okay?
So like a static analysis in some way, you can call it.
right.
In order to get some sort of.
What you're talking about is
sense of
risk assessment of the existing
Yeah,
system.
it's really establishing
Yeah.
a baseline right at the beginning. for
Right,
right.
security.
But now we're taking it to one level further. We are saying source code analysis as well. So
I'm sorry, what?
you're saying a risk analysis of the system, risk analysis, which also includes the source code analysis. That's what you're saying, asking for.
The source code of what?
Source
Well,
code
I'm not so
analysis.
sure.
Oh,
if
the
it's
So we're
source
saying
code.
that is the stored procedure, supposed to
Oh,
use a
the
Trojan?
source code.
The
And-
source code
and-
for the stored procedures,
and
but
to-
not for MySQL.
And to try and assess whether a stored procedure is a bad stored procedure or a good
Yeah.
stored procedure.
Well, I can also imagine that, and this you can write down and take back to the, since you're the CTO, take back to the engineers and say, do this. I could imagine that you could, when somebody does create a stored procedure, do like a, recursive kind of like, what is that doing? And then kind of automatically add a new rule. If you want to monitor that stored procedure call, you can then add a new rule that says, well, we know this stored procedure changes this and this, so make sure if they do run this procedure that this and this are changing, and nothing else. Or, you know what I mean?
Right, but that's sort of that's if you're monitoring while the stored procedure is being created.
But I don't think it would be that difficult for when, say, the database, either the database starts up or the monitoring starts up, whether it was a restart or the first time, to go and look at all that information. I mean, if you already have the parser to parse out what it does in real time, I don't think it would be that difficult to just do a selective.
That's what I was
part.
referring to when I was
Yeah.
talking about dependency check.
By parse, I mean take it apart and figure out what it does, which is what they do with every single command. The monitoring software.
That kind of
Yeah.
stuff, that's called
That's
basically
not-
dependency
no.
check, that if you dependency check, and a lot of systems already have it built in, like for example Sybase. You
Right.
can go in and do type sp depends stored procedure name, and it'll tell you that what are the other dependent stored procedures and what are the dependent tables on that stored procedure. So in other words, you're saying that if this stored procedure runs, it's going to affect these stored procedures and these tables. right?
So
But
what-
again, the complication over here is that it can be dependent on logic within the stored procedure.
Right.
So it could be these tables,
Right.
or it could be that table.
But Sybase also expects you to know the name of the stored procedure you're looking to examine. In my case is, there may be a stored procedure stored in there that was put in there months ago, just waiting to be invoked, that's going to wipe out the employee table.
Yeah, but monitoring, like the risk assessment
Yeah.
is happens before monitoring. This product doesn't do the risk assessment per se. It does the monitoring from the time you put it on. Now for risk assessment, you can do some basic checks very quickly. You can write some scripts for that, and there are some tools in the market that do risk assessment as well. That are your roles appropriate? Things of that nature. Is your patch level up to date? It'll do things like that. But the source code analysis, analyzing that this stored procedure is really harmful or not harmful, it's very difficult. There are some products that will do some basic kind of checks.
I wouldn't doubt that it's difficult at all. That wasn't, what I'm asking is, do you recommend that your clients go through this risk analysis prior
yeah,
to your
absolutely,
installation? That's
absolutely.
all I was asking.
Okay.
To make sure that you start out with a clean database that is a known thing.
Absolutely.
Okay.
And actually we have a professional services team and what we go and do as part of before our installation is sometimes we offer free services to do a risk assessment. So we just to get the customer on board and make him feel that, that we can offer some kind of a service before actually sending him a bill. We actually go in and do some risk assessments just free of charge for Oracle, Sybase, DB2, and we can pick up any vulnerability scanner which is available in the market and do that. We per se don't provide a product to do that, but we offer the professional services to do that, just because we have a team that understands databases and can look at that information that comes back and quickly make things out of that. But yes.
Okay. Thank you.
I have a question. If my application have a direct access for database API doing database activity, how can you monitor my application?
Right. Now if it has direct access to the API,
Yeah.
if it is direct access over the network, or it is all local.
All local.
If it's all local, so the question is that it is bypassing the SQL engine completely.
Right, exactly, because I know a lot of financial application where they direct access the API.
And I'll give you one example in the MySQL world, which is the NBDB API.
Mhm.
The cluster API that's out there, and it uses direct calls, memory calls to the server. So the only person who can monitor that system is the database itself,
Right. Mhm.
right? So if you have an application of that kind,
Mhm.
which does not, which accesses directly through the API,
Mhm.
that cannot be monitored by any other system other than the database itself. You could, if it was going via shared memory,
Uh-huh.
and if the shared memory structures were exposed or documented, then some vendors could come back and say that we are monitoring the shared memory structures as well, so we can understand the message in the memory structure itself.
Mhm.
But there are few people who do that. One of them is Quest software.
Uh-huh.
So they would, but they are always host-based agents. They're sitting on the system. They're very tightly tied to the same API, which the other application is using.
Mhm.
Right? So the question was that if it's going to be direct API access to the system, there may be a few applications out there, and the ones that we have really run into are JD Edwards on a iSeries IBM box, where JD Edwards and the iSeries box were all packaged together by IBM and provided all on the same system.
The same story with embedded MySQL. When you link together MySQL
Into the
and your
application itself.
into the
Exactly,
application.
exactly.
Yes, you
Then-
can't use this to monitor your cell phone that runs MySQL, so.
Yeah.
But in
Those are
most,
some of the things that cannot be monitored. It's a good question.
in most cases though, especially with something like the cluster database or whatever, I mean, that has to be a local application
Yeah,
using,
that's true.
even with the cluster database, you're still usually making remote network calls to that cluster
Uh-huh.
database. You need a local thing writing an API, and if you're going to go steal someone's credit, if you could do that, you can get a job anywhere. You don't need to steal anyone's credit card number to make a lot of money.
That's the point, right? Because we want to
MySQL
stop
will
it.
hire you. So.
Right. You know what happened is, the point
Right,
is,
Patty?
they tried to stop DBA, right? Why not stop the application programmer? The application programmer can direct access. the-
Absolutely a good point, and that is why in most of the environments, application
Uh-huh.
programmers are not supposed to have access to the operating system. That goes back to really the first point, that who's supposed to have access to the host,
Mhm.
right? And if you're going to let somebody onto the system if it's going to be your standard application, which was already assessed for its risk, and then made available in production environments, then you shouldn't worry about it too much. But yes, at that point, you will have to basically embed the code in your application to do some of the level of auditing if it's important.
But didn't you also say that using the programming languages that use the API, you can still monitor them?
Yeah, if they're going to come over, most of them are going to use some form of TCP/IP. Just to give one example, we have a big implementation at a company called Vonage. So we know Vonage, right? It's a big
voice over IP.
Voice over
Yeah,
IP
they have the most annoying
and they have a
commercials.
lot of MySQL, and for the billing system, right? A lot of MySQL. So what they did was they have a lot of local activity, like the application database are all, they have like 50 boxes, each one of them being like nodes. Applications are on the same databases, but they still use IP. And the reason for that is they develop these applications using, so that they could be distributed if they want. They could pull the application apart from the database and put it on another machine, so they could extend their system. So in that case, right now, we have local agents running on those boxes because a lot of that activity that they generated, even though it was IP, it was all local to the machine. But they could have written an application if they were, most people, the point I'm trying to make is most people write an application which has a distributed architecture so that you can pull that application out of this database server machine, put it on another machine, and should work just fine. Right? So most people build their applications that way in the client server world. But there are some situations, and the good example I gave you was JD Edwards, using DB2, which is all in the same box. It just directly uses files. It knows exactly how to manipulate using the API. And the reason they built the system that way was like a turnkey solution for certain segments of the industry who will never pull those things apart because to them it's one black box. When you turn on the server, it brings on the database. It does not even have a SQL engine. It does not have a SQL engine. So you can't write a SQL query against it. You can only connect to it through the API. But there are instances of databases out there. So this kind of auditing will not apply to those situations. I mean, we won't be able to do that unless the application per se has auditing built in. There's no other way around it. The applications have to be instrumented. So there are situations that we cannot monitor. Okay, thank you. Okay. So here we just create another rule, monitor my table. So that's how you create a rule. Just run through a couple of things real quick. Simple access policies that you can create. For example, if you had root user, and if you're going to restrict, if you have some IP addresses from which he's going to connect to the system, and the reason I bring it up is because some of the environments that I worked in previously, they would turn on some OS level monitoring for super users. So all the super users are supposed to connect through this one system. If they try to connect directly, either they will already have a tool that's blocking them, or it will be a policy violation. That has to be identified. Simple things like, let's say a PeopleSoft ID is only supposed to be connected to the database server from the PeopleSoft application server and not from anywhere else. So there you clearly know the IP or the IPs. So you have this unique combination of the database username and the IP addresses. So you can create simple data access policies around that. The example here is that if the shared web application is coming in from this IP, then it is trusted. But if it's coming in from anywhere else, then it is untrusted. So here's the star. So immediately, if shared web gets used by some developer to connect to the production server, the whole session is marked as untrusted, and it's available in a separate set of reports. Okay. At this point, let me show you a couple of reports. Okay, that might be interesting.
I think we also turn into pumpkins in about 15 minutes.
Okay.
We are. I mean, we've gotten late, but usually like at 2 hours, we're all kind of like.
And that's it. I'm going to round it up. This little thing over here is going up and down. I don't know how to
It's
stop
very
it.
annoying.
Yeah.
Where it comes from?
Popping up and down.
Yeah, it's because of this card I have here.
Yeah.
And I don't know how to stop it right now. So the reporting system that we have is built around MySQL Server reporting services today. And I was just having a conversation with a few folks who were here a little bit early that we're looking into the possibility of using Jasper and a MySQL database. So right now it uses the MySQL Server reporting system. And the reason why you see a lot of folders here is because we have a common reporting system across our two products, Logcaster, which collects all the operating system events, and Informant, which collects the database events. And the reason I told you this is important is the database, if you're not monitoring if the operating system of the database on which it resides is secure, then there's some critical portion of the database security that you're not addressing at all. Okay? So we monitor all the operating systems as well, Unix platforms and Windows platforms and everything.
By what means you monitoring, which means how often you pull in the data?
Well, we are always monitoring the logs that are generated by the operating system. So once you turn on auditing, those logs are monitored in real time.
Okay.
So if there's a security event written to the log, we would catch it right away
Okay.
in real time from all the systems. But
So
this is
You use Jasper for like analytics, or for what you use Jasper for?
pardon?
You use Jasper, you mentioned. Right? You
Oh,
use Jasper for
No,
analytics.
we were just going to use it for the similar kind of reports that I'm going to show you right now.
Ah, okay.
They don't use it yet. Right now they use
Okay.
We don't
SQL
use it
Server.
yet.
They
We
want to
SQL
use
Server
it.
reporting services.
Excuse me, where is this data stored?
This is stored, actually it's stored in the appliance, in files.
In
And
files,
then-
not in a database?
No, and then it gets transported to this database on a scheduled interval into MySQL Server. And then you can run your reports using either the reports that we provide, or you can generate your own reports using the report builder that comes with it.
Right. Well, you don't want it
There's
to
a report
not
builder.
be able to log
Why you
because the
don't
connection's
go
down.
directly to the database? Why use files as intermediate?
Okay, and the reason for that is that this data is transported back to many other systems. For example, security information management platforms, and not everybody wants the data in the database. So there are certain agents that run on our box that are sending these feeds to some other systems, and the delimited format is the easiest format to interface with.
Okay.
So here are just one high-level report, let's say.
It can be a CSV database. How's that? Then everybody will be happy.
It's actually a TSV for us.
Well, no, there's actually a storage engine CSV, so.
Okay. So here I'm just going to run a simple report.
Yeah.
And I'm going to run the report only for MySQL systems that we're monitoring, because we monitor all the systems exactly the same way. So either it is a DB2 or Sybase or Oracle, it's exactly the same. Let's just restrict our report to MySQL. It could be restricted further just by IP addresses and port numbers, or by criticalities, or you can restrict the reports right away by user. So if you're looking for all the traces by root user, you could just put in the root user right here and just run the report for the root user. Now this is a full-fledged reporting system, so you can either run the reports interactively or you can schedule them. You can export in any format, you can send emails, you can email links, you can send PDFs, you can do everything with this. This system is really slow.
Well, you're doing everything MySQL for a whole year, so.
Okay, so now these are some, let's look at these events. An audit table was accessed. A failed supervisor logon, system table changes, login information was scanned. Privileges were granted to users, tables were altered, password changes, failed transactions, all these things right here, right? So now you could drill down, let's say if you're looking into failed transactions. You could click on them and drill down into further details. Now this is an interactive report. So you can schedule any one of the reports, a very high level report. Usually in interactive mode you'll start with something very high. The auditors typically start from this report, what are the alarms that went on in my system? Let me see that. Then you want to get to a second level where it's more actionable data, where here's the username, here's the IP address, here's the exact SQL query that was issued by the user. And then if more analysis is required, you want to go get back into the complete session trail. That's what I wanted to show you, from login to log out. What did this user do? And you can actually get to that level. So here, we're just focusing on all the failed transactions that happened, and most of them were login attempts that were failing by user Troy. But the next one that actually failed by Mel was when he tried to set a password for Troy. Okay?
Yeah.
So now you're seeing who is doing these queries and when they're coming from, which IP they're coming from, and it can immediately trigger a suspicious behavior right there. Now, if you wanted to go into more details, let's say the whole session, what is Mel up to? Why is he setting this password? And so I clicked on the user name now, and I'm trying to get to his session details. Let me see everything he did, because now this is starting to look a little bit suspicious.
Is it the network or it's just slow?
I think it's the network, because the transfer is so slow. So here, now we are focusing on the MySQL database session by user Mel, and here you can see his login. Now he's done a bunch of other queries, and you can actually see them being executed. There's a query number assigned to it, 0, 1, 2, 3, so exact order in which these queries are occurring. And we are going down and we're seeing these queries. You see that.
Do you assign that query number, or is that something that the
No, we assign these
MySQL
query
does?
numbers automatically.
Okay.
Yeah, there are certain metrics that we add, and one of them is the query number. Okay, to see the sequence the events. So here you can see that here's the query,
Yeah.
and it says unknown column. So what is succeeding, what is failing? We're getting the complete trace of his session, which is going into a couple of pages. And here at this point, his 12th query was the one which actually set off the alarm. It said set password that failed. Unknown system variable password. There was a typo. There's a typo here. So that's how we came to know. And then if you go to the end of his session, you will see the logout. So you started with the login and you ended up with the logout. So we saw the whole session trail. Okay. So this is what people really like. That you are able to go back and focus and drill down on specific sessions of interest. So you start with very high level alarms where you capture the significant events, then you go down to the actionable metrics, and then you drill down to the final detail. Okay. Now there are many reports I don't want to show you, we are out of time, but just to show you, what are some of the reports that auditors really like. I'm not going to run those reports, but I'm just going to show you what they are. If you need any more information, you can always contact us. Okay? So that's not a big deal. And just to let you know one thing, for MySQL, today we are certified against 4.x, not against 5.x. So we will be completing our certification for 5.x only in July timeframe, I think June or July, end of June, early July timeframe. Okay, so if you want to try it against 5x, you will have to actually first try it against 4x for now, and then 5x in end of June, July timeframe. So, these are not even reports. It's just to go from one folder to another. It's taking too much time. So here, we organize them into database activity reports, performance reports, management, security, and compliance reports. So under security and compliance, we have a bunch of other reports. And then we group them into PCI and Sarbanes-Oxley and other things. Let's say if we were just to drill down into the PCI, the typical things that people will ask you is log on, log off reports, user account privilege changes, database schema changes, accessing audit tables, and policy violations and things of that nature. So we create these reports, like stock reports, and put them in the appropriate folders.
Is there anything that you particularly like graph, or is it all just log type stuff?
Well, we provide a lot of raw data, and if you want to graph stuff, we work very closely with many tools. Like for example, SIM platforms, who will do a lot of fancy graphing and charting. Our tool per se doesn't do a lot of fancy charting.
Right.
We
But
like to
what?
do that.
But what are some of the things that you log that you could theoretically chart, for instance? Or is it just like number of
No, we
errors in a certain time frame you could chart, or?
Histogram.
Database
Yeah.
performance.
a lot of things.
Database
Database performance could be one of them.
That's right.
Activity baselining. We want baselines for everything. How many queries from this IP addresses? Is it
Right.
normal? Is it not normal? You can chart almost everything.
Okay.
What are the top users? Show them in a form of a chart. Queries by top users. Why is John doing 50 million queries and everybody else doing so little?
Top 10.
All those kind of things. Top 10s.
Yeah. Or bottom 10. I think most admin will be interested about top 10. Who is the top 10 user have a big problem in RippleTech.
And we do have some reports over here which have some basic charts like bar graphs and all that. I didn't show you those, but some of them are there already. We have some performance reports. I've not shown you any of those things today. Let me round this up. So here we created when we got the server appliance, we created monitoring rules to monitor the server. Okay. Then what we did was we created these from these stock rules. We added these stock rules to start looking at the significant events that are happening in the database. We can go in and modify those commands. For example, here we're looking for a prohibited command. Okay, this is a stored procedure. Then here, when that actually gets executed in the reports, you will see that the prohibited command was issued. When you click on it, basically you see the details. That here's the exact command that was issued by user SA at this time, and then you have the option of actually drilling down into the details where you can see the login, every single command, and what happened. So this is basically the summary. These are some of the popular reports. I can give you the slides later on that people really ask for, and people really need to pass audits. These are some of the popular alerts, but really sky is the limit, because we can do things like if there's anomalous backup going to a USB drive as opposed to going to a tape, you could find that out and things of that nature. So we can do all kinds of correlation, but this is just to keep the list very simple and short.
Now, what about SSH sessions?
Good question. Actually, if there is any encrypted session, encrypted sessions you cannot monitor over the network. So that is really the issue with monitoring. Now, what we are finding in a lot of environments is encryption in motion is not being used a lot. There are certain cases in which it is being used, but most of the times you are in a secure network and people don't use encryption in motion. They mostly use encryption at rest if they want to, and they will encrypt only specific columns, but encryption in motion is not being used. And as we talk to some of the encryption vendors and see how this technology is going to evolve, because we can expect that there's so much talk about encryption in motion right now that everything is going to be encrypted. We feel that that's going to be the case. Here's what we're learning what's happening in the industry right now. Some of the key leading encryption vendors, they are putting on products which work very much like ticketing systems like Kerberos. So anybody who wants to participate in encryption actually goes back to the encryption server to get the encryption keys, and intrusion detection systems like ours who participate in the security policies get access to those decryption keys, so that we then at that point we don't have to do anything different other than decrypt the packets. We already have the key to decrypt the packet. But those solutions, not us or nobody else provides decryption on the fly today.
But you have to make, you have to make agreements with those companies that provide that type of encryption, right? I mean, have you done that with like SSH and
No.
Open SSH?
There are different ways to do encryption in motion, right? SSL, for example, it's endpoint to endpoint, right? And the only two people who know about the encryption key is the client and the server. Nobody else knows about the key at all, right? Then how are you going to decrypt it?
Right.
So companies who are leading encryption vendors like Cipher Optics, what they have done is they said, I have an encryption policy server, and the client and the server get the key from the policy server, and the IDS is going to we'll make that key available to the IDS. And the reason for going through all this stuff is because companies have millions of dollars of investment in IDSs. They have snorts, they're used to doing network-based monitoring. Most of the large organizations will always have a huge millions of dollars of investment in network-based monitoring. And all that monitoring becomes useless if you encrypt everything. And most of the times the problem is, now if there are hackers who are coming into your system, you are encrypting all that stuff. Now you have no idea what they are doing to your system as well. So that is the, unless you have all this auditing inside the database itself, right? Or in the endpoint. Because how else are you going to figure out what is somebody doing? If you can't monitor them over the network, then you have to monitor at the endpoint, which is the application. So that is the difficulty that companies are going through, which is why these encryption vendors have come up with a better solution, saying that it's going to work in a slightly different way than what the SSL vendors thought it was going to be. That, client to server direct. But that is not a very scalable option for an enterprise. So SSL is not being adopted the way we think it is being adopted.
Right.
That's what we are learning when we talk to encryption vendors. And today, if you see encryption in motion, it's usually happening over unsecure networks and not within the secure enterprise. So once it's going over the unsecure network, that's where you end up seeing encryption. So many people, like when we went to Vonage, they said, we are surely going to use encryption. They never used it. So everybody talks about it, but nobody uses it because there are even performance implications, right? So there are a lot of things, and then it's not a very scalable situation. They lose their whole monitoring infrastructure. The whole network team becomes upset. They can't really use that. So there are a lot of downsides to that. But what we did with the DB2s and Oracles and Sybase and MySQL, we categorized all the alarm into alarm groups so that we can report upon them very quickly. So audited applications, schema changes, and database maintenance, or failed logons, or failed transactions, we grouped all those events that were happening into appropriate alarm groups so that we can report upon them very nicely. And here's what a raw data looks like. Now you were talking about the metrics earlier, right? That what is it that can I match against? How can I write those rules? Now there are so many metrics to match against. So here you see the login by user SA. And he said, I'm going to use this database, insert into this table, and then when he did the delete, it failed with a foreign key violation, then he logged out. So here's how we stored it in our raw files. From login all the way to log out, with so many metrics. You're seeing query numbers, and you're seeing usernames, and application names, and error message, and error severity, return rows, IP addresses, query text, database names. If the OS username is available, we'll even capture those things. Okay? So now you have the power of using any of these metrics to create any complex expression that you want. So you were talking about, can I restrict to this IP address? Yes, client IP address is, and client port is also there, client IP is there, server IP is there. You can create rules to your heart content. We just gave you the basic stock rules out of the box, but you can customize it to any level. Okay? That's it. There are many other requirements in an enterprise, and this is just a short list. Like we have already thrown out ideas like that repository that we capture has to be secure, it has to be tamper-proof. All that stuff has to be thought of when you collect this data. Because if you're going to use it for forensics, and if you don't secure the data, useless. So when we create the data, we create digital signatures of the data, of the files that we are creating, and we store those things. So we take a lot of precautions. The appliance that we capture this data on is a secure appliance. Nobody can log on to that. There's only one ID available to log on to that. Okay? And it's a hardened server. So there are a lot of precautions that go into creating these final solutions. That's it. It costs $182 for every single record that gets stolen. That's the statistics right now. So if you had 10,000 customers, just multiply that by 10,000. That's what it costs an organization today.
TJ Maxx.
TJ Maxx.
Good luck.
Yeah.
Thank you very much.
Really.